Question 2 reads, the length of human pregnancy is approximately distributed with a mean of 266 days and a standard deviation of 16 days. Part A reads, what is the probability of randomly selected pregnancy lasts less than 260 days? So the first thing we're going to do is we're going to turn this value into a z-score. So 260 days minus 266 divided by 16. We're going to get an answer of negative 0.38. Next, we're going to use our standard normal table to find the proportion that corresponds to the z-score of negative 0.38. And our proportion is going to be 0.3520. And this is our answer. Part B asks, suppose a random sample of 20 pregnancies is obtained. Describe the sampling distribution of the sample mean length of human pregnancy. So we are going to assume that this is approximately normal. And then since the mean of the population is 266 days, the mean for this sample is also going to be 266 days. Now for the standard deviation, we're going to do the standard deviation of the population divided by the square root of n, of the sample n. So when we plug it in, we have 16 divided by the square root of 20. And when you solve it, we're going to have a standard deviation of 3.58. Question C says, what is the possibility that a random sample of 20 pregnancy has a mean gestation period of 260 days or less? So the first thing we're going to do is that we're going to turn this into a z-score using this as n. So since this is about a sampling distribution, we're going to use the formula to turn this into a z-score. We're going to use the mean of x minus population mean divided by population standard deviation, which is then divided by the square root of n. So let's plug in our numbers. And we get a z-score of negative 1.68. When you use your standard normal table and you find the proportion that corresponds to the z-score of negative 1.68, you will get a proportion of 0.0465. Question D is asking, what's the probability that a random sample of 50 pregnancy has a mean gestation period of 260 days or less? So just like last time, but this time with a different sample size. So let's plug in our numbers. And we're going to get a z-score of negative 2.65. When you turn this into a proportion using your table, you're going to get a proportion of 0.0040. Now part E is asking, what might you conclude if a random sample of 50 pregnancy resulted in a mean gestation period of 260 days or less? So it's asking us about the question before. We would say that this result will be unusual. The reason why is that this 0.040 is less than 5%. Or 0.05. Now part F is asking what's the probability a random sample of size 15 will have a mean gestation period within 10 days of the mean. So this means it could either be 10 days less than the mean or 10 days more than the mean. So that's what they mean by within 10 days. So 10 days less than the mean would be 256, and 10 days more than the mean will be 276. So we're going to find a z-score for both of these numbers. So let's use our formula, and we're also using a sample size of 15. For the first one, we're going to have a z-score of negative 2.42. And let's find the z-score for the next one. Notice how one side is positive and the other one is negative. That's because they're the equal distance away from the mean. Now, if you find the proportion that corresponds to the z-score of negative 2.42, using your table, you will find a proportion of 0.0078. Now, you could either find the complement or use your table to find the proportion that corresponds to the z-score of 2.42, and either way you will get a proportion that would be 0.9922. Now your last and final step is to subtract them to find the area in between. So you would do 0.9922 minus 0.0078, and you will get an area or probability of 0.9844. This will be your answer.